Okay, so this is where we left off. Mrs. Morales. Mrs. Morales teaches computer programming. Each student writes an average of 9 lines of code per hour. That's how coding is considered, by lines of code. Complete the double number line, to find how many lines of code a student could write in a given number of hours. Guys, this is just patterns. I know when you were little, you watched Timu Mizumi and they said, pattern power. I know you've seen that. And I know I'm an excellent singer. You don't have to tell me. That's all this is. It's just a pattern. It's just repeating it. So look, the pattern up here is it's going by ones. 1, 2, 3, 4, 5, 6, 7. And down here, it's going by multiples of 9. Okay? So if she can do 9 lines of code in 1 hour, then double the amount of time should be double the amount of lines of code. So we have 9, 18. This is 3 times as many, 27. 4 times as many is 36. 5 times as many is 45. 6 times would be 54. And 7 times as many we can see is 63. So it's just pattern. It's just, you may know it as skip counting. Okay? It's all of those things when we're looking at ratios, because starting with that first ratio has to continue that pattern. All right, Mrs. Sanchez also teaches computer programming. Each of her students is able to write an average of 4 lines of code for every 20 minutes. Write a rate using the quantity 1 hour. Ooh. Then describe what it means. So this one, I know you're looking at it already and you're like, whoa, 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 whoa. There's fractions here. I did not sign up for fractions. I'm terrified. So first, let's talk about the information they gave us and the fraction that they're using. So they told me they can do 4 lines of code every 20 minutes. How on earth is this 1/3 related to 20? Think about it. Did you figure it out? 1 hour is equal to 20 minutes plus 20 minutes plus 20 minutes, because it's the same as 60 minutes, right? So one segment of 20 minutes is 1/3 of an hour. This is another third, this is another third. So if these fractions are stressing you out, let's just write 20 minutes above this one. 2/3 would be 40 minutes. 3/3 would be 60 minutes or 1 hour. 4/3 would be an hour, 20 minutes. 5/3 would be an hour, 40 minutes. And 6/3 would be 2 hours or 120 minutes. Okay, so you can always add more information if it makes you feel better. I know it seems like more work, but you can do it. Okay, so it says write a rate using the quantity 1 hour, then describe what it means. Well, we just found 1 hour, didn't we? Right here, 3/3, 60 minutes, which is 1 hour. So we can say that a student can write 12 lines of code per or for every 1 hour. That's how I would write it. One student can write 12 lines of code per hour. Always read your ratios from top to bottom. 12 lines for every hour, 12 lines per hour. So this fraction bar can say per, or it can say for every. For every. That's how we often read it in math. Okay, let's see. 2 ratios can be compared if they both have the same amount of one of the 2 quantities being compared. Which class writes code faster? Well, we have something we can compare. We both know how many lines of code they can write in an hour. You probably know the answer to this without me writing anything. Okay, the first one, part A, that class, we'll call it class A, can write 9 lines in 1 hour. Class B can write, we figured it out, 12 lines per hour. So who's faster? Class B. They can write more lines in an hour, so they get more done, so they are faster. Okay, let's check right here. Compare the ratios in the table. Are they equivalent? Explain. So we're comparing cups of peanuts to cups of raisins here and here. Okay, let's see. When I'm comparing ratios, I'm sorry, we're comparing them this way. So we're comparing these ratios to this ratio, right? Okay. All right, so we're trying to see our 5 cups of peanuts for every 3 cups of raisins. Is that equivalent to 3 cups of peanuts for every 2 cups of raisins? Let's keep going. What if I compare 10 for every 6 to 6 for every 4? What if I compare 15 for every 9 to 9 for every 6? Okay. Now, those maybe are not the best ways to look at it because all of these quantities look different. So let me try again. That didn't help me. I'm going to look in the table for something they have in common. So right here I can see for Liam, he has 6 cups of raisins. And over here for Sam, this is where he has 6 cups of raisins. Okay, so Sam is 10 cups of peanuts. I'm going to write P for peanuts for every 6 cups of raisins. And Liam does 9 cups of peanuts for every 6 cups of raisins. So are they equivalent? Equivalent just means equal value. You can see that in the word, equal value. Are they the same? Do they have an equal value? No, they're not equivalent. Sam's has more peanuts. Or you could say Liam's has less peanuts. They are not equivalent. All right, last one on this page. Miss Marcus also teaches computer programming. Each of her students is able to write an average of 5 lines of code every 30 minutes. Which class, Mrs. Marcus's class or Mrs. Sanchez's class, writes code faster? Well, which one of Mrs. Sanchez's class are they asking us to compare? Well, let's look at it this way first. So 30 minutes, and then again, I see fractions here. These fractions are a little different because we're talking about 30 minutes. I know 30 plus 30 makes 60, which is an hour. So this is 30 minutes. This is an hour. This is an hour and a half. I'm gonna write 1.5. This would be 2 hours, and this would be 2.5, 2.5 hours. Okay, so right here, we can see that, who is this? Mrs. Marcus's class can write 10 lines of code in 1 hour. Oh, I'm sorry. I could keep thinking this is all Mrs. Sanchez, but this was Mrs. Morales. So Mrs. Sanchez's class was this one. Mrs. Sanchez, we discovered, they can write 12 lines of code in 1 hour. So who's faster? Mrs. Sanchez's class. She's faster than all the classes of that school. Either she's a great teacher or kids are just faster. Okay, let's see. Let's do a couple more. All right, a track coach has runners perform drills to practice for a track meet. Each runner is supposed to run 5 sprints for every 4 full laps. So sprints are when you run really fast. Laps are all the way around. Megan runs 11 sprints for every 8 full laps. Did Megan use the correct ratio for her running drills? Well, let's find out. Oops. Sorry. Okay, so this is what they're supposed to do, and this is what Megan did. So what we need to know is, did she do the right thing? So first, let's complete the table. So if this is times 2, 5 times 2 gets me to 10, this should be times 2 as well. So that's 8. Let's look at this. This is times 3, so 5 times 3 is 15. This is times 4, so 5 times 4 is 20. So here's what she was supposed to do. Let's see Megan's table. This was times 2, so let's do 11 times 2 is 22. This would be times 3, so 8 times 3 is 24. This one's times 4, so 8 times 4 is 32. All right, so compare the ratio of sprints to laps that each runner is supposed to run to the ratio of sprints to laps that Megan ran during practice. What row in each table has the same first or second quantity? So we're looking for a number they have in common. So do they both have 5 anywhere? No. Do they both have 10 anywhere? No. 15? No. 20? No. Let me go this side. They both have 4 anywhere? No. They both have 8. Ooh, look at that. 8, and 8. So here's what they are supposed to do. I'm going to write R for runner. They were supposed to do 10 sprints for every 8 laps. Megan did 11 sprints for every 8 laps. So we can compare those quantities because now we have the same quantity for at least one of them. Think about it like a recipe again. If I don't have the same quantity for one, then I don't know which ones, how they're different. It's too hard for me to look at all these different ratios. We might as well use something they have in common. Even though they're on different rows of the table, we still kept them together, sprints per lap. Okay. So did Megan use the same ratio of sprints to laps that her coach asked her to run? No, she didn't. She was supposed to do 10 sprints for every 8 laps, but she ended up doing 11. So no, she ran more than she needed to. Suppose that Megan wants to run more sprints and laps. How many of each could she run so that her total sprints and total laps are in the ratio the coach wanted? This reminds me of that paint mix-up that we watched last week. Remember that? Okay. So, of course, there's more than one possible answer, but let's look at this. Right now, she's up to 44 sprints for every 32 laps. Okay. That's the bell, sorry. That's what she's done. What the coach has asked her to do, the last ratio after that is 20 sprints for every 16 laps. So these aren't equal yet, but I can easily make 16 into 32. What if I just double these? So multiplying by 2. Now I'm at 40 sprints for 32 laps. Are we getting anywhere with that? Okay, so maybe those numbers are too big. What if I look at, what if she could just run 4 more laps? 4 more laps. So that would bring her first total 11 plus 4. That would get it to 16. I'm sorry, not 16. Holy moly, guys. 15. Everybody makes mistakes. Okay, and then 8 plus 4 will get her to 12 laps. So here's sprints, here's laps. And that ratio would be equivalent to, let's write it on here, 15, 12 would be equivalent to 5/4. Okay, I don't really love thinking about adding to make ratios correct, but I can see where they're going with that. Same thing as the paint. So do you see how these are equivalent? You could multiply by 3, multiply by 3. All right, let's try number 4. Vivian scored 8 out of 10 on the quiz. Ramona scored 3 out of 4. Did Vivian and Ramona get equivalent scores? Well, let's see. We have 8 out of 10, and we have 3 out of 4. Now, we changed fractions to decimals last year, so you might have some idea about this. An easy way to do it, like any grade, is you think of it as being out of 100, right? So now we need to ask ourselves, what would I multiply 10 by to get to 100? It's 10, right? 10 times 10. So then 8 times 10 would be 80. So Vivian got 80 out of 100. What do we multiply 4 by to get to 100? 25, like quarters. 4 quarters make $1. 3 times 25 then is 75. So did they get an equivalent score? No, Vivian did better. All right, I'm going to give you a few questions to do on your own. Let's look at them here. Oh, they're going to be these 3 questions here. This one, and this one. They're going to be on Canvas, so they'll look a little different.